So I will go to the last presentation with the title Gas Phase Air Cleaning Effects on Ventilation Energy Use and Indicators for Energy Performance. So I'll show you what we suggest and which also mentioned by AIVC, which indicator to use to evaluate the energy performance of a gas phase air cleaner. I myself, professor at the Technical University of Denmark at the Center for Indoor Environment and Energy. And most of this work here was done by, at that time, a previous PhD student, Dragos, who was involved in this study, which I'll present for you. He has finished his study, so there is a PhD report, and we are right now making a paper with additional results. So when we today are looking at how to establish design ventilation rate and how much you should ventilate, we in both ISO and CEN, but also an ASHRAE standard, are looking at how many people are in the space, and we have some data for how much you should ventilate per person. But we are also looking at the building itself. How can we, what type of building is there? Is it a building where you have taken care of the materials, low emitting materials, and so in the standards you get some benefits, so that the building component, which you see here at the right hand side, is less if you have a building with low emitting materials. And the basis for these, adding these, the building part and the person part, is referring to the influence on the perceived air quality for people in the space or coming into the space. So it's basically how you perceive the odor level, the irritation, that form the basis. So the perceived air quality is, in that regard, an important parameter. So then, to get the total ventilation rates, we have this equation, the number of people in the people part plus the area of the space and the building part. But to find out how much you need to put in the supply, you also have to take into account the ventilation effectiveness, which in most cases is mixing or complete mixing. Then it's 1. Displacement ventilation, it may be 1.2. And if you have a personalized ventilation system, it may be even going up to 2 or a little higher. So that's how we estimate or design our ventilation system. And that's important to have in mind when we now are going to look on also the implication or energy implication of using air cleaner. And what we want to do with the air cleaner, we want to find a value which we call the clean air delivery rate, which is comparable to the ventilation rate. And for this, we're using perceived air quality, PAQ. So we need to do a test to be able to find this clean air delivery rate. And we can do that by doing a test where we measure perceived air quality. You see different equations here, but basically what we look at is how many people are dissatisfied with the air quality, depending on the performance of the air cleaner or how much you ventilate. I'll go back to that. I will refer to one test we have done, but we have done more tests with different air cleaners. One we were using was based on absorption. So it had active carbon, but we also have done studies with some of the others using PCOs, ion generation, and so on. So these will react in different ways. I'll come back to that. But the thing is, we want to find a test method where we can find the clean air delivery rate of the air cleaner. And we still have to do that by using people. And we're using people in two ways, because the most common source of pollutants in the space is the emission from people. So to do a test, you'd both need emission from people, emission from the building, and you need people to evaluate the performance. So what you see here, if you look at the photo in the middle, we have two persons who evaluate the air quality coming into the room, and you see a screen, and behind this screen we have an air cleaner, and we also have people who is acting as subjects emission from people. They cannot see it. And the other part of the room, we also have a cupboard which are ventilated with building materials. So we simulate here emission from building materials. And there's two ways we do the testing. Other people go into the space quickly in the first take, two deep breaths, and then they evaluate the level of odor, the perceived air quality they feel. Or, which we have done here, we take on the right-hand side, we take air out of the space, so people don't go into the space, but they have a funnel where the air from the space are being provided. They do an evaluation. We have two scales, an acceptability scale, how acceptable they find the air. We can also use the odor intensity as an evaluation method. They gave relatively the same results. The important with this test is that it's a relative measurement. So we do the test with and without the air cleaner in action. So it's a comparison we are really using in the test. From this acceptability, where you have the scale on the right, you can have clearly acceptable, or you can have a clearly not acceptable. But you have to choose, are you on the acceptable level or the not acceptable? But based on these values, called ACC here, we can calculate the perceived air quality. Or basically what we calculate first is a percentage of people who are dissatisfied, doesn't find the air acceptable. These are based on older studies, especially done by Pavel on sensory pollution sources in building. So these are data and relations that we have found in studies we did a long time ago with people. And then we can get on and also find the clean air delivery rate. So what we did, let's see if I can remove. We had here two studies, and what you see from this is we find that this dissatisfaction rate, which is called the PD on the axis here, on the y-axis, percent is dissatisfied, and here we have the ventilation rate. And we do then the studies where we can, for example, simulate only building emissions. So there we didn't have people in there as source, or which are more related to how it is in practice. We have bioeffluent per people and building emissions as a source. And then we do a test without air cleaner. You see here the red circles. That is the relation between how much we ventilate and how many are dissatisfied without the air cleaner. And then we put on the air cleaner, and then we get the blue ones, and you see we get less people dissatisfied. And the difference between those is really the clean air delivery rate from this air cleaner. We will see that it varies where you are on the scale. At the moment, we are working on a standard test method. We have a standard test method when we're working on a standard how to establish clean air delivery rate. And we will probably say you have to establish it based on 20-30% dissatisfied, because that's the normal level we are working at in buildings. So this particular study in finding this clean air delivery rate, we can also talk about percentage efficiency. So if you have a higher efficiency, the clean air delivery is higher. But it's important not only to talk about efficiency. You have to talk about efficiency combined with how much air is going through the air cleaner. But the clean air delivery rate is the absolute value for what is the equivalent clean air you get from the air cleaner, and can compare with the ventilation rate. So now to evaluate the energy use, we did the first study, which I'm talking about here, is building simulations. We don't have any field study. That's really what is needed. And we hope that will be some of the results we can get from a new annex. You have heard about the proposal from AIVC. So this again is a building simulation where we simulated a system, heating and cooling system, with or without a heat exchanger. And so we looked at the energy use, both for heating, for cooling, and for ventilation. So it was electricity for the fans, but then also the energy, which could be electricity, or could be other sources for the heating and cooling. In this study, which was done for Copenhagen, so it's mainly heating we are talking about. And we had the study where we did it with two building types, a low polluted building, LP, and a very low polluted building. And we did it with and without the heat exchanger. To evaluate the effects of the air cleaner, we introduced a parameter, which was also mentioned by AIVC, called clean air efficiency. And the clean air efficiency is a relation between how much clean air are delivered, the clean air delivery rate, and the energy use for obtaining this clean air delivery rate. So it's liters per second per kilowatt hours. We do that because then you can compare the effect of using an air cleaner with the effect of just increasing the amount of outside air. If you increase the amount of outside air on your system, also has an energy impact on fan power, on additional cooling or heating, depending on what area you're in, maybe also dehumidification. So that's the key performance index we have introducing to evaluate different ways of improving ventilation in a building. And if we looked at these first results, as I said, we have done now other analysis which are on the way in the publication. I will not show them here, but I think it will be published in 1 or 2 months from now. So in this studies, we have here on the y-axis clean air efficiency, so liters per second per kilowatt hours. And we have then a study, for example, VLP is a very low polluted building. And here you have a low polluted building, both with a hex means it has a heat exchanger. The two others are without heat exchangers. And then we had two types of energy. That is one where we only talk about the energy used for the air handling unit, and the other where we also have the auxiliary energy for running fans and other electrical consumption. So that's the one which are really used for the comparison. And then you see two lines below here, and that is for two different levels of clean air delivery rate, or for energy use of the air cleaner. So one where you have the full line has higher energy use, and then you have an air cleaner with less energy use. It depends a little on what type of air cleaner. Do you have a standalone air cleaner? Is it built into your system? For example, if it's built into the system, depending on what type of air cleaner, it may have a pressure drop, which increases energy use. And it may also use energy itself. For example, so if you use a PCO or a plasma one, you need energy, electrical energy. So the energy performance, how much energy you use for the air cleaner, is also an important parameter. But if we looked at it for Copenhagen, you see if you have a heat exchanger, then it's always better to use the ventilation air to improve the indoor air quality in a heat-dominated place. If you don't have a heat exchanger, it may be better an advantage also to use an air cleaner. So to use a heat exchanger is a very important, and of course the efficiency of the heat exchanger. In Denmark, we require an efficiency, I think it's about 80%. So that's the efficiency we have used in this calculation. But I can say we also now for a new paper, having the results here, looked at a climate like Tokyo, where you have more cooling and you also have dehumidification. And in this case, both with and without a heat exchanger, you get a better performance using a clean air delivery rate from an air cleaner. Again, depends on what type of air cleaner, it depends on how much energy the air cleaner is using. So what you should get out of this is that it's important when you evaluate, is it better to increase the air, ventilation air to obtain the same effect, or does the air cleaner help you? And you can compare those two by using the clean air efficiency, so liters per second clean air delivery rate per kilowatt hours to obtain this air delivery rate. So that was basically conclusion that clean air efficiency can be used to compare different solutions. So in Copenhagen, with a high heating load, the gas phase air cleaner was competitive only if the air handling unit did not have a heat exchanger. But as I said, we have new results that if in other climates, it may always be important. And this again, something we will continue looking on in a new annex proposals, which we hope can start doing this year. So that was the end of my talk, basically to introduce this KPI, clean air efficiency, which you can say you also here require a test method to establish this clean air delivery rate. And I can say we have one standard showing how you do the measurement, how you measure perceived air quality. And we are now working with a technical specification, a standard-like document that shows you how you do the testing, and that should be finished this year. So we will have a standardized test method available also. Thank you.